We're on.
I don't think so yet.
Not being recorded. Try again.
Okay, it should be okay now.
Yeah, there it goes.
Okay, there it goes. We are here. We're back. It is time once again, ladies and gentlemen, for the SBAU Astro Hour. 1 hour long vlog. Sometimes we go long, or if you just want to hear us, it becomes a what's the other thing? Blog and broadcast. Blog. What's the word?
I don't know. I was never clear on that.
Well, anyway,
Podcast.
Video log.
podcast. Pod. Yeah.
Yeah, podcast.
We're here every Monday morning, live from our dens and our man caves, 11 to noon for SV Astronomical Unit, Santa Barbara, California, South Central Coast Longtime Astrophysics Telescope Club. I'm your host, Ron Heron. I learn a lot from my buddies, my very knowledgeable comrades in the SBAU, and I'll be introducing what I call the Brain Trust here, our panel in a moment. Watch us on YouTube live Mondays, 11 to noon. Come to our first Friday meetings where we got great speakers like Nicholas Vogenow. Not going to believe what kind of things he's going to point out at the sky about on the 2nd of August. That's at the Museum of Natural History up in Mission Canyon. Check us out on let's see, what is it? SBAU.org. And there's all kinds of outreach activities, including our second star parties. And we have a lot of fun. We've been doing this over 3 years. We're 3.5, now our 4th year. And here's what we're going to talk about this week. Welcoming new neighbors out in space. I guess neighbors to the galaxy. It was a close game. Sextans 2, Virgo 3. And I got that last score in the last few minutes. At Saturday's Star Party, held with extreme cloud cover, we went anyway, and our guys managed to zero in on our waxing gibbous moon. Even took a picture witnessing the egress of the star Spica. And we saw some other things and had 75 visitors. Won't believe some of the names bestowed upon the moon's surface by the IAU. We're going to take a grand tour of the side of the moon facing us in this hour. Herschel's garnet star is Musephiae. It's huge and it's about to die. And we do have a lot of fun with the gang. Let's meet the gang, because he's the man behind the cartoons and the thought provokers. Jerry Wilson, beloved president. Jerry,
Good
5
morning.
years. Have you kept track? Is it 6 years?
No,
It's not.
I tend to not count the years.
Well, I think it happened. It's long before the pandemic. And he's married to Pat Forgey, and a veteran of the old Hollister R&D days. Chuck McPartland is too, SBAU outreach coordinator. He's married to the other Pat, who's our merchandise manager, as well as newly elected this year treasurer. Tom Whittemore is out of town. Bruce Murdoch signed in. He's married to Bonnie. Bruce, nice to have you aboard. Thank you for volunteering to do a speech on N bodies or N something or other.
Well, I was going to redo the speech that we did 3 years ago, but then Farshad Barman, you've been on that email stream, has been investigating the galaxies that circle the sun. I'm sorry, circle in the center of the Milky Way galaxies, and emulating that. So he's going to give that. We didn't think we could do both of them in 20 minutes.
What does the word N stand for?
More than 3.
No, it can include
galaxy. Yeah, right. The one we did 3 years ago, whatever it was. I simulated the orbits of moons around planets and planets around the sun. 39 total bodies.
I know. So why is it either P or O for orbits or P for planets? It's N, and
it's
don't know.
It's N for number.
Number.
Put 39 objects. Arbitrary number.
Okay, and he's married to lovely Bonnie, and Tim Crawford's married to Karen. Tim?
Howdy.
President, longtime lens and telescope expert. And ladies and gentlemen, it is time for our silly science cartoons. Some of them are thought provokers and definitely worth seeing. We got about a dozen forwarded to us by the president. Here's the 3-minute car wash, followed by about an hour and a half of washing pigeon poop off your car when you drive it out. Good luck there.
I didn't get that the first time I looked at it, but I sure do now.
I missed the 3-minute. I thought it was 1 minute for a car wash. No, there's a 3 in there.
Yeah, you're just going. It's just a circle. You just drive back through.
You know, we're losing our
you.
car wash. Have you noticed, is that something having to do with changing times? You know, we're losing bowling alleys, we lost skating rinks and arcades, and now we're losing all there's, I think the Upper State Street Car Wash is closed.
I thought we kept our ice rink.
Yeah, we did.
That's the third ice rink in Goleta?
Yeah.
Yeah, the one in Goleta's
Yeah.
new. The one I used to work at is up on the Mesa.
Yeah.
Well, that
Ice
went bust.
that-
And then there was
we lost that.
The one out here in Goleta is the third attempt for an ice rink.
Yeah.
Well,
The
I
other
heard
two went out of business for some reason.
Yeah, and a lot of restaurants are closing down. Here we go. This is a little biblical. Technically, ladies and gentlemen, Moses was the first person to download files from the cloud to a tablet. Actually, he had two iPads, and he was
If you saw the History of the World Part 1 with Mel Brooks,
right.
Yeah.
Moses came out with 3 tablets.
Three
He
of them, and he
says,
broke-
the Lord sends these 15, and then he drops one and he corrects himself. 10 commandments.
Somebody pointed out 9 of those 10 are just about property. I'm not sure what the 10th one. Here's a couple of elderly. Whoops. You want to go back to that one or stick with
No,
this?
this
Oh,
is
I
it.
like this one.
All right, things are turned on their side if you look close. Phew, my God, Margaret, it must be 90 degrees outside. And then he went down below. You can't go to that back one. There we go. A couple of elderly scientists are looking up at something outside, while in the background you have the UFO landing and the extraterrestrials, since they are not outfitted with a bathroom. They're not self-contained. He's out taking a leak against a tree. I understand totally. But it's yellow on my screen. I think it was green. And okay, something on the moon they discovered. Tom's cat or Chuck's cat, I think, looking for large kidder litter. And kidder
Actually, it looks like my cat, and I wouldn't put it past her.
Yeah.
Chuck's cat is all black.
I have all black and a Siamese, so it doesn't count.
You know, I had a woman Saturday night come up and say she loved astronomy, but didn't think the moon landing actually happened.
Oh, God.
One of
Have
those
you
people.
seen the new movie out called Fly Me to the Moon?
No.
I heard about it.
No, and I was one of my favorite stars. Scarlett Johansson is in it, and I'm very, very disappointed she was in that movie. But one of the people that was at my Sunday talk, she was a young woman who was selecting her career, and she wanted to be a set director. And I said, well, Fly Me to the Moon is about set directing, because it's faking the moon landing.
Oh, you know, I have heard of that, Jerry. I
Yeah,
have heard of that. I haven't yet seen it, but yeah.
yeah.
Well,
I
one
kind
of
of
How do we
avoided
handle
it.
Apollo 13?
Here's a couple of Caltrans guys having a discussion out at Turnpike. You see those vehicles over there taking an alternate route? You know, we need to start construction there too, guys. That's how they decide.
There's a lot of construction around here lately.
Yeah, I
and
tell you,
some of it is-
I was coming south the other day, and you know where they did that underpass on the northbound?
Yeah,
Well, now they're going to do the southbound side.
yeah, they've switched the freeway over.
So now we got another, 3/4 of a year to go to wait for that.
I think more like a
20
year and a half.
2026.
God, you'd think the infrastructure can't last forever, for crying out loud.
Certainly can't.
Here's Elon Musk's plans to send SpaceX actually to the moon to harvest cheese.
Green cheese, huh?
Green cheese.
Yeah.
I hadn't thought of that.
For the audience that doesn't remember, back in the 50s, the rumor was that the moon was made of green cheese.
Yeah, I
And there were
know.
a number of MGM cartoons that relied on that myth.
Well,
And
I'm-
Wallace and Gromit.
Yes, and Wallace
Yeah,
and Gromit,
right.
Fine Day Out or something like that.
I'm sure we'll be seeing lots of cheese in the many pictures you're about to show us in this hour, Mr. President. Okay, on the stage, Homer Simpson is the random guy, and we have a scientist against what's going on today. Look at this. Scientist has several degrees, 10 years of study, a PhD, and has published books. The random guy, that's Homer, is on the internet and has watched a YouTube conspiracy video. So, God, he knows what he's talking about, doesn't he?
Yeah.
Those are
Plenty
the
of those
ones-
around.
Those are the one. Blow this up a little bit so I can read it. That's not Homer on the left, but that is Bart, isn't it?
Yeah, it's Bart. Oh, that's the principal at the school.
Oh, is it? Oh, okay. And he
Yeah,
says to the kid, you know, there's nothing more exciting than science. You get all the fun of sitting around still and quiet, writing down numbers, paying attention. Science does have it all. A lot of
All the
kids
boring
think,
parts of it.
yeah.
Yeah, and look at the parts expression.
Yeah, you can't
Oh,
argue that.
really?
The voice of that character was a woman.
Yes, I
Had
heard
a
that.
hit record. Yeah. Okay. We don't get enough respect, us scientific types. I could have been, I think, a halfway decent scientist. I wouldn't have known as much as you guys, but
Which
we're
half?
gonna focus on the moon a lot. Here we go. But first, oh, here we are. Our new neighbors.
This is the bubble galaxy.
This is a doc or a discussion of the, what are they, dwarf galaxies around the Milky Way. And these suckers are so dwarf, they're really hard to spot. And this is a dashed line put around the members that are identified as part of this remnant galaxy. The most obvious dwarf galaxies we have are the large and small Magellanic Clouds, which were used by, they're visible to the naked eye, and they were used by ancient mariners to as navigation aids. But this one is, what was it? One of you guys asked the question, how do you spot these, just before we went on the air? And this is actually how you spot them. This is a field of view, or a field of stars and galaxies in the background. But we're usually looking at these things with a lot of foreground stars. So you want to tell the structure thing, the galaxy, from the foreground stars. So you measure something, you look spectroscopically at these guys, and you just do these stars, you survey them. If you think there's a collection, and you measure their radial velocity, and if they're clumped, they're probably an association, probably moving together. Random stars wouldn't move like that. And so you plot them like this, and you can tell also, if you can measure their distance, if one of them happens to be a Cepheid variable, for example, then you can get a good distance for the association once you've established that it's an association. And it's quite an effort to find these things. They found about 36, I think, in our total, in our galaxy.
Or 60, I think.
60, okay. And but some of the other galaxies around us have 100 or more, several hundred, and models have placed what should be around our galaxy at around somewhere between 200 and 500, depending on whose theory you look at. So this is a newly discovered.
Jerry, the Cepheid variables, those are the type 1A supernova?
No.
Oh, okay.
They're the variable stars that have a period luminosity relationship. So you can, when you measure the period, you know the luminosity, and now you can know the distance.
Okay,
yeah.
Very good.
It's one of our standard calendars. The newly discovered dwarf galaxy Virgo 3, Roman numeral 3. So this study is largely based on information taken by the Subaru telescope on Mauna Kea, Hawaii. We took a tour of that facility one time, a friend of mine, Gary, and in the Subaru dome, they keep those things refrigerated to the temperature they think it's going to be about 3 a.m. the next morning. So you always need a parka and gloves when you go into these observatories in the daytime.
But don't they pick up stuff on video cameras, and you're in a warm room to look at them?
Yeah, well, nowadays, looking at them, the graduate students and the technicians are up on the mountain. The astronomers are down at Hilo, at sea level, in a warm room. Everything is electronically relayed, what's happening. So the content providers and the data gatherers, that's down at Hilo. The rooms are warm. It's the graduate students that do it up at the mountaintop.
There's a great book called The Last Stargazers by this lady astronomer. And she's saying, yeah, you're losing touch with the nighttime sky because everything is done over the internet.
That's right. It's just like a lab science now. I was talking to an astronomer about that, and of what we do in our club. And he said that he didn't know, if you showed him a constellation, he wouldn't be able to recognize it because he's completely unfamiliar with the naked eye sky. But we actually come from an era when visual was just ending its reign.
Okay, you lost me halfway through there, gentlemen. The little circled items on the inside the big circle are those are stars?
Yes.
Galaxies.
Those
So
are
those
stars.
are stars.
Oh, okay.
There are galaxies out here. There's a galaxy there. This
Right
is
in
a
the middle,
galaxy, but that's not what we're talking about. This
know.
association of stars in this circle, these smaller circles, these are members of the dwarf galaxy Virgo 3, Roman numeral 3. And there's,
Oh,
what's that?
now I'm getting what you're talking about here.
Oh, okay.
I'm glad you asked that question. So now I get
Yeah.
it.
Yeah.
And the ones with circles are probably the ones they studied, and the ones that are outside are the ones that weren't part of the association.
Oh,
Yeah, they just might be drawing around the biggest part of the association too.
Also, yeah.
You have to pick out, you have to ignore the stars in the foreground here, and then things in the background like this and this. So you're looking at this dwarf galaxy, which is just like almost like an open cluster outside of the Milky Way, but it's got things in the background and it's got things in the foreground because you're looking at it through the Milky Way. And so we can only spot a certain fraction of these things from where we are because the Milky Way is in the way.
huh.
Oh, we're looking through the Milky Way.
Yeah.
Through the
So
main
this
part.
shows where on the sky this is. And there's a lot of, it's near the Virgo, it's in the Virgo cluster area. And there are other galaxies, real galaxies out here. This is our association again, Virgo 3. Yeah, Virgo 3 and its member stars. So it basically started as a galaxy, and it came in and it orbited our galaxy. And as it's been going around and around, it loses its gas and dust if it had any, and it loses its stars. It slowly fades away as the Milky Way adds its stars to our galaxy.
And the same thing's happening to Andromeda.
Andromeda has satellite galaxies too. The one that is studied for this is more. Let's go back to this. This is the
Sculptor galaxy.
yeah. Thank you. The Sculptor galaxy NGC 253, and this is the one. It's a beautiful, almost edge-on thing. But this one has been studied extensively, not in this picture, but it has an irregular distribution of, let's see, where is that?
I think that's near the end, talking about how
Yeah,
it has an irregular distribution, and the anomaly between theory and what we're seeing around our galaxy could be if we have an irregular distribution and we're not looking toward the concentration.
you remember it better than I do, and I edited it. Thank you.
And this is the one below Cetus, right?
Yeah. The silver coin galaxy. Yeah.
Silver coin, right. This is a beautiful, beautiful galaxy in a telescope.
Yeah, this is 11.5 million light years away from Earth. And it has, as Chuck pointed out, an uneven distribution. So we measure an uneven distribution around our galaxy just because we can't see in all directions. So we can only measure things in the way we see. Some theories put it that we should have about 500, and other ones put it down lower, 100 or 200. So they're still working on that. But the distribution
Called the Virgo cluster, isn't it?
This is not the Virgo cluster. This is the dwarf galaxy cluster around our Milky Way. The Milky Way is right in here at the center. This is the Large Magellanic Cloud, the Small Magellanic Cloud. This is the two that were just discovered, Sextans 2 and Virgo 3 up here. So this gray is the disk of the Milky Way. So they're not like right on the edge about to collide with it, but they are orbiting our Milky Way. These are galaxies that we've sort of used up. I hear a lot
Some
of
of our
crickets.
globular clusters may also be remnants of some of these.
Yeah, the idea is that some globular clusters, which are really quite old, might be remnants of previous galaxies that might be the core of previous galaxies, and they do not go around the Milky Way in the plane of the Milky Way. They form a sphere around the Milky Way, much like these dwarf galaxies do.
Huh. So like a shell, sort of like the
Yes.
Oort cloud is to the solar system.
Yes.
But if you see any major galaxy in the distance, that's all you're seeing is that galaxy. It probably has hundreds of little dinky galaxies we can't see, right?
It probably does, yes.
And science probably thinks that if there is life on any of the planets orbiting any of the stars in these dinky little satellite galaxies, they're probably just as much alive as we are and have just as much of a bright light, and has nothing to do with the size of the galaxy they're in, does it?
It's what star you're orbiting.
Yeah.
Yeah, okay, right. Amazing. I thought we only had about a dozen or so, Triangulum and Magellanic Clouds. And
Triangulum's not a dwarf galaxy. Triangulum is like Andromeda. It's another full-on galaxy.
oh, it is?
Yeah.
Yeah, the three form a set, Andromeda, Triangulum, and us. Not necessarily a triangle, but they're similar galaxies and similar distances away.
So Jerry, now I'm a little confused. The Virgo 3 galaxy.
Dwarf galaxy right there.
Oh,
It's hard to see the gray on my monitor.
Oh, okay.
When it comes on my monitor, it gets brightened up, and a lot of the dimmer things just disappear.
Okay.
Oh, I see. There they
So
are.
this is the word Virgo 3, and there's a gray arrow pointing down.
Right. Now I see it. It's very, 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 very big.
Yeah. And Sextans 2 has a little gray arrow too.
Yeah.
Okay. That's right. I didn't troubleshoot the effect of different monitors. Oops.
I'm confused with what you're trying to show here.
Yeah, well, I'm trying to show this.
Oh,
This is what our sky looks like of where these things are. This is a globe with declination or right ascension lines starting here at 22 hours, 20 hours, 14 down to 2 hours. Cetus 3 is over here in a triangle. Virgo 3 and Sextans 2 are down here near the galactic equator. And these are other dwarf galaxies distributed through the northern hemisphere of our sky. So if you want to show them at outreaches.
Well, we need a really dark site for some of those.
you have to be in a different location.
Yeah. Now there's an amateur astronomer who's been quite active in this. I guess he has pretty good equipment. So his name is Giuseppe Donatello. And these are dwarf galaxies. Donatello, he got dwarf galaxies named after him.
So he's French.
He's Italian. Sounds Italian to me. So these are pictures that he took of the dwarf galaxies that he's discovered. This is Donatello 1 through Donatello 9, as seen by the dark energy spectroscopic instrument. So,
it looks like DESI has the 6 diffraction spikes too.
Yeah.
Oh yeah.
In the upper left there, that middle
line.
Yeah. So these are taken by the James Webb Telescope.
Well, I think the DESI isn't the DESI an earthbound detector?
It is, but it wouldn't give that necessarily that pattern. Well,
yeah. Anyway, it looks like a 6 spiker there.
Yeah. So it's taken by the dark energy spectroscopic instrument, and they're looking for. They want to measure the motions of these objects, because it does give an indication of the dark energy and dark matter distribution. These we're about to bring online the Vera C. Rubin Observatory in Chile, which will give a much better look at these objects. These are among the observation list for that telescope.
But does this whole network around us of galaxies and orbiting little galaxies represent like a node in that lattice work web that's supposed to fill the universe?
Yeah.
No, that web is on a much larger scale than all of this. That is a diagram of clusters of galaxies. And here we're looking way inside. We're looking at just one or two galaxies. In this case, we're looking at galaxy or dwarf galaxies around NGC 253. And the previous stuff we talked about was the new dwarf galaxies around the Milky Way. So we're looking at individual galaxy systems, not even up to the scale of galaxy clusters.
Well, I thought the word node might work, a collection.
Yeah.
And then there's a string of them, and then there's a big void in between.
That's on a much bigger scale than this, much bigger.
Oh, I understand that, but I just wondered if we represented one node and virtually every other big galaxy we see out there has got their own little node going.
Well, Ron, the node we would be part of would be like the Virgo cluster, the whole supercluster, I mean, that's a really large scale node structure. So we would be a tiny, tiny, tiny little point within one of those nodes.
Well, that word Virgo is overused.
That's the direction in the sky that it is.
It's an easy target.
Okay, gotcha. What does sextans mean? Do you know where they got that?
Sextans is the constellation. Sextans the sextant.
Oh,
Yeah,
it's in the southern sky. We don't see it up here.
The device for navigating. All right.
Yeah, it comes above our horizon, but it's dim.
This is probably a really great place for me to ask this question too, because I think that's what you're leading into. Is that how are these dwarf galaxies going to give us some kind of idea of dark energy?
Well, they more dark matter.
Yeah. Oh, dark matter?
Yeah.
Okay, dark matter. So the dark matter does have mass.
Yes.
And this, of course, is the NGC 253, has its own collection of four dwarf galaxies. Now we're just about we're at a moon phase called the waxing gibbous. We're just about to become full. I think full is later this week.
Yep.
What is it, the strawberry moon or
just well, it's the 21st.
It's the flower moon, I think. So this shows features that you're likely to see on the moon. Right now, the terminator will be running right down around this region. So it'll look very much like this. This thing here is called the rack of pool balls.
Really?
It's not a triangular rack.
Yeah.
Okay.
And Gruithuism Gamma Mountain. So it's a good region to look around. This is in good shadow. You can see a lot of pressure ridges and rises and domes and vanished craters in this region by the subtle shadows around the nightfall. Actually, this is the sunrise part. Now, Sky and Telescope had a set of 20 or so features on the moon that are named by amateurs. They're not accepted names by the IAU. They are just common among amateurs. And those are features that we know quite a bit about because they're obvious things for us to see as amateurs when we look at we show the night sky. This is the stepping stones, these things in a row. Have you seen these, Tim?
No.
Okay.
Some of them you have.
Some of them I know you have. One of your favorites is in here. But these are not. Go ahead.
Go ahead, Gary.
Talking those four in a row, those four craters?
Yes.
Yeah.
Huh.
It's a line of these things. They look like stepping stones. People refer to them informally as that. The IAU
is one of those Theophilus or
No. Tim, there are Cleomedes, Burkhardt, Geminus, and Masala.
Huh. No, I'll look for these.
Okay,
Those are the names IAU gave them.
this is called the headlights.
Ron, those are the names of the craters. Yeah, the IAU names of the craters.
Okay. Think I've seen these. Why did they splatter differently than making a big round bowl?
It's
Well,
because of the way they hit and what they hit.
They did, Ron, but it's two smaller craters on either side of the big one that have the splashes.
But they are
And the craters,
meteor impacts.
These only show up at full moon when you see this. So
Yeah.
Complete lack of shadows. That's when you see rays from craters. And these two craters look like headlights.
And it's really blown out on your monitor, Ron. That's why you can't tell there are two little craters.
Oh God. I gotta work on that.
Oh, so there are craters there.
Yes.
Okay. Now this one is called the Lucky Charm, or the Good Luck Charm. Can you guess why?
Four-leaf clover.
Three-leaf clover.
Yeah. Well, it's 4 leaves.
Oh, I see.
Okay.
There's
Yeah,
another
now I
leaf.
get it. Okay.
There's one up there and there's one back there. So it's a very foreshortened 4-leaf
Oh,
clover.
yeah.
Yeah, Pat says you threw that in for Ireland.
For Ireland, yeah. This is called the Liebig wall, as opposed to the straight wall. Similar feature along here.
Obviously.
It has an official name too. It's Rupus Liebig.
Hmm. And that's a C there next to it.
Yeah. This is called the Hills Waterfall. This bright thing right there. Optically, in a telescope, it looks like a waterfall. And
Really?
These are real nice. I'm going to be looking more at these things.
mm-hmm.
I like the moon. I like it.
Yeah. I have to go back and reintroduce myself to it. And because when I take pictures, I regard the moon as an obstacle to taking pictures. But it does have interesting features.
It's close. It's our close neighbors. You really get a lot more detail.
Yeah.
See, Tim, and you were complaining about Westmont being on a full moon night, but you can
not anymore.
Now you got new targets.
Yeah.
People love the moon.
It's not been
called the Spider.
And you were calling it the strawberry moon. I think it's going to be the fog moon.
Yeah.
Fog moon.
Let's hope not.
I hope not.
Makes you wonder in the future, guys, which countries are going to claim territories with which craters as theirs.
Well,
I think it's going to be a lot like Antarctica. When you build a structure there, everybody sort of leaves their hands off it because they know that's your territory. But the vast majority of the land is going to be unclaimed.
Well,
yeah, I think people who are signatories to the space treaties say, you can't claim the moon or large tracts of the moon. But if you land something there, it's like your sort of monument or your event,
Your landing pad.
Yeah.
Well, we don't seem to be interested in the far side that we don't see, but China sure is.
It gives them new territory to claim first discoveries, and they are getting interesting stuff and doing good work.
Yeah. Jerry, speaking of fog moon, our last star party, we had that occultation of Spica. We got really, really lucky because the moon was completely covered, and right about 8:53, it cleared up enough so that we could actually see that occultation Spica poke out from the bright side of the moon. It was really, really quite nice.
Yeah, Dave Larson showed me the picture on his iPad.
Yeah.
Now, can you see this feature, or is it washed out?
We could see it.
Okay, this is called the Spider.
Be damned.
And don't try and count the legs. It's not that good of a representation.
I won't be looking for that one.
Looks more like a jellyfish.
Typically one big splash and a lot of later on little splashes.
Well, yeah, I think those are ridges, but
yeah, I'm wondering about that. I'm wondering what created those ridges. It wasn't part of it's not part of the rays, is it?
Pressure.
Mm.
As the moon contracts, as it cools, you get these cracks and
Right.
Okay.
It's just like on the Arctic Ocean where you have ice flows and icebergs where they crash together, they create a pressure ridge.
Oh,
Forces
okay.
upwelling of
Okay.
ice. This is exactly the same, but it happened largely when the stuff was liquid underneath, but it does happen even when it's solid.
I've been there in the Arctic tent near pressure ridges. Both the ones that are opening up and they crack a lot, and the ones that are coming together, they groan and grind and make all kinds of noise.
Okay,
keep you up all night.
Yeah.
this is called the lunar S.
Lunar S?
Yeah.
As in the circular cute.
It's in the letter S.
Cute. Okay.
RST. See right there?
Where do we see? No.
Well, it looks to me more like it's lower, like it starts there and comes all the way down to the bottom.
Oh, it's on the bottom
there?
here.
Yeah.
What you were pointing out is a backwards S.
This here.
Yeah.
It's a
Yeah,
leading.
you're starting near the upper crater there.
That one?
If I can interrupt just for a second, we have a guy online.
Oh, you're right.
We have a guy online, Joe. I'm sorry if I mispronounced it. Joan Gale. And he says it's called the buck moon. A male rabbit is called a buck.
The buck moon. Okay. Thank you.
Yeah.
Yeah, these full moons have multiple names.
Male of the rabbits are called bucks.
Oh,
Yeah.
you're right. I was pointing out the wrong S. I'm dyslexic, so you can forgive me for that. So the S is here.
This one looks pretty subtle, but that's, appropriate.
Yeah, a lot of reaching in my view.
S for subtle.
Oh my God, what is this?
This is, I think that's called the heart dome. Oh, the Valentine dome. It's supposed to look like a heart. It doesn't, it looks more like a biological heart than a Valentine heart to me.
But there's, actually there's a dark zone up and right of it that looks more like a heart, more like a Valentine.
Oh yeah, yeah,
Oh,
yeah.
yeah, real faint, yeah.
Yeah.
Oh, I'm sorry. She said it. Her name is Jo Lynn. I was really mispronouncing that. So thanks, Jo Lynn, for the info.
Yeah, that's probably the feature they're talking about.
Is there a name for that straight line of little craters?
No, not that I know of.
Well, that's kind of interesting.
Ron's line.
Ron's lines, yeah, you got a new asterism named after you, a craterism.
Maybe it was a comet breaking up like the one that divided itself upon crashing into Jupiter.
Yeah.
It was Shoemaker Levy.
Yeah, on the moon, no less. Wow.
Okay. Now this is called the heart of the moon.
Yeah, you can see that.
Yeah.
I don't get that one.
The
Well,
bottom of the heart is pointing off toward about 4 o'clock.
there's the heart, there's the point.
It's kind of a dark region. Depending on the
Yeah.
contrast on your monitor, it might be hard to see.
Okay, I got it now. I see it.
Okay.
It's pretty big.
Getting this, Jo Lynn? Welcome aboard.
What's this one, Tim?
Oh, there's my favorite, man. Look, the Lunar X.
And this is actually a bad picture of it.
I got a picture.
The Werner Cross, Purbach.
Yeah.
Let's see, Purbach Cross and Werner X. I can't remember the whole bunch
This
of different
one
names.
actually, when you see it on the moon in a live scope, it actually looks better than this photograph.
Yeah.
Yes.
This photograph's a little over-processed.
It wasn't at an ideal time either.
Yeah.
Now I think unlike what some websites, they call it different things, but I think there's the two craters, Werner and Purbach. I think they overlap, and that's what creates it. But I'm not sure of that because a lot of people say, no, two different craters.
Yeah, it's two different craters, but their walls intersect like that.
Yeah.
Yeah.
Yeah. See, it's three. Here's one crater there, and something down here.
So there's maybe a few craters
and
that
something
effect.
over there.
Yeah.
Yeah. This is the common parapet between these in this
Yep.
quadrilateral.
Yep. And I agree. It in in a telescope, it looks completely different, much more
Right.
obvious.
And
But
you
it
can
is
pick it up in
transient.
binoculars.
It only lasts for an hour or so, or a couple hours.
Yeah, it's the next time it's visible for us is August 11th from 5:28 p.m. to 8:02 p.m.
Hmm.
What are the times, Chuck? One more time.
August 11th from 5:28 p.m. to 8:02 p.m.
So we might get some of it, huh?
Yeah.
Okay.
Otherwise, you don't see it.
Otherwise, you don't see it.
Yeah.
Yeah.
It just disappears in the clutter.
Well, I think we should land a NASA lander there.
Oh, Lunar X is really cool. I had a couple of good stories about that with kids. But
Oh yeah, you got to tell that story, Tim.
yeah, a little kid ran into. I used to observe from this place I called the Cubby Hole at the museum, which is gone now. And this little kid ran in and he goes, "Did you see the X on the moon?" And I just said, "What? Do you think they're playing tic-tac-toe on the moon?" And he said, "Yeah." And I said, "Well, who's winning?" And he said, "The O's."
Yeah.
with no hesitation at all. The
Yeah.
O's. he was something
He's a
else.
quick pickup.
He
Yeah.
was a quick thinker.
He's right.
Okay.
There's a lot of O's up there.
This is the tadpole.
Kids are sharp, boy. They're really sharp.
Yeah. This is the lunar tadpole here.
Looks like the
Oh.
sign of a whale.
I'm going with tadpole.
Well,
Yeah.
where is the
Whale doesn't
tadpole?
have a string tail.
The whole thing a tadpole, or am I missing something in the middle of the picture?
This white thing.
Yeah. Although if you look at the crater just to the right of it, it has a tadpole tail too. So there may be multiple.
Oh, yeah, yeah.
Okay.
Yeah. This is, of course, the famous straight wall.
Yeah, there it is, boy. And
Or
Bert
the
off to the left,
sword. The sword.
sword on the moon. And then Bert is off to the left of the sword, I believe.
Yeah.
How high would you be up above if you were riding on it?
1,100 feet, I think.
That's something like that. Yeah.
I think it's 1,100 feet. I can't remember how long it is. 20 miles, something like that.
Oh, longer than that.
And about
Yeah. I always forget that. I keep looking it up, and a month later I'll forget it. But it's they say it's not it's really not a cliff. It's kind of more like an angled wall.
Yeah, it's
So
a slope.
They call it an escarpment.
It's a thrust fault.
huh.
And this is the sword tip. This is the guard and the pommel back here.
Wow.
This is called the Guardians, and I think it refers to these two massifs right here that guard the entryway to the what is this? Rill?
Alpine Valley or something.
Yeah. The next one, something I've never heard of, called, and you're probably going to have this hard to see on your monitor because these are rays. They're two parallel rays go up here called the railroad tracks.
Yeah, I can see it.
Okay.
You know that last one, Jerry, that little pathway. I bet
Yeah.
if you were walking on the moon, would that just be huge high cliffs off to either side of you?
Yeah, this would be like walking in the Grand Canyon.
Wow. Wow.
Going to be a lot of exploration in the future.
This is
Yeah,
like that
yeah.
scene in The Hobbit where they were cruising down the river toward the waterfalls, and there were two big statues with their arms held up
Mm-hmm.
that the river is going between, but no falls.
Maybe it's part of a Cecil B. DeMille set
Yeah.
Right. No, it's part of a Fly Me to the Moon set.
or a Kubrick set, or how they staged the landing with Scarlett
Mhm.
Johansson.
Well, you heard that joke, right? That it's true that that Kubrick filmed the moon landings, but Armstrong demanded that they film it on scene, on site.
Yeah.
True location.
I'm sorry. This is called the Ghosts of Procellarum. And it's a series, obviously, from the lighting, you can see that this is full moon. These are craters that are almost completely invisible because they've been flown or filled with lava flows. and this one has been eroded away. So these craters that are almost gone are called the ghosts of Procellarum.
Huh. Neat. That's neat.
So that's not the IAU name, that's the common name we gave it.
All of these are common names.
Yeah.
Oh, okay. Got it.
This one I don't find in there what they claim it is. It's called the fireman's hat.
Huh.
Yeah, depending on the country you're in, you could make up several in here.
Yeah. There's something prominent here with this and then these two earlobes on it, sort of reminiscent of Mickey Mouse, but maybe that's what they're referring to.
That looks more like Alfred E. Newman.
Yeah.
Oh, you're right, it does.
What? Me worry? Huh.
Okay. Now this one is really obvious. The next one, it's called
That's a cool one. Yeah.
Thor's hammer. As soon as I can get this to work. Okay,
Thor's hammer. Oh,
right
That's
there.
Oh, yeah. Oh,
what is it?
It's a mountain.
Oh, okay.
See right there where the cursor's moving?
It's shaped like Thor's hammer
Yeah,
or a question mark.
I don't see the question mark.
Well,
the
it's,
top of the question mark is squashed.
yeah, it's
Okay.
It's in the middle of a mare, right?
Mhm. Now this is a crater that's a very old crater that's been filled with lava, and then it got a new addition here in more recent times.
That looks like Copernicus there.
Yeah, it does.
Huh.
Now this is the cobra head,
Cobra, yeah.
which no mistaking what that is. On the edge of a sea already, because there's a lot of old craters that are filled in by the lava flow. And then here's another more recent impact. This one hit something and stuff flowed out, or it flowed in, because as you get down this way, it gets wider and wider.
Yeah.
So either it started out emptying this thing and then petered out as it went down here, or it accumulated from all the way up. So my sense is that it started up here and it went down there and then was absorbed to nothing by the time it got down there. Probably
Okay.
not water.
The tributaries left on the moon. Wow.
And this one is called the Ninja Star. Oh no, this is the Ninja Star. It's a series of rays taken at the full moon. This is those little pointy things that ninjas throw it in the Asian movies, the fighting movies. So the observer, obviously, that named it had a history of martial arts. This is called the Golden Handle. It's in, what is this, Marimbrium? And this is the bay out here.
Okay.
The official name for it is the Jura Mountains. But at this time, it's just the mountaintops show up as the sun is rising.
That's another one that would just be, you got to catch it at the exact right phase, like the Lunar X.
Yeah. Now we're moving on to
Here's another one of my favorites.
This is
the only thing missing. The only thing missing, Mr. President, from your grand tour of the moon was a face, like there's one on Mars. We need to find a human face.
Oh no, there's faces on the moon too.
There are? Well, those would have been fun to watch.
The man on the moon,
you have a vivid imagination and you dig down deep enough, you'll find all sorts of things. The human brain likes to find patterns.
Likes to find faces.
Yeah.
Well, the one they found on Mars, they haven't been able to duplicate it. The sun hasn't.
Well, when they got a higher
exist.
resolution picture, the face disappears.
Yeah,
Yeah,
it's
that's
just
true.
yeah.
Okay, we're now in the sky.
Yeah, and we're looking at Herschel's Garnet Star. This is
Ooh.
Polaris, so we're at the north, near the North Pole. This is Cephas. In my mind, I draw a line across there, but this line down here is, this thing down here is Mu Cephi, and that's the Garnet Star.
Yep. This is a good one, boy.
So this is easy to find.
And it's very red.
This is the star. It's very red. This
Yeah.
ring around here was added by a human hand. It does not occur around the star if you photograph it. This bright star over here.
I don't see the house stars here. I don't see the outline.
Oh, well, it's not. This is zoomed in.
Okay. Okay.
Yeah, this is one of the stars of that. This one here. Oh, I think it's this one.
I think it might be the IC, but well, that's a cluster though.
Yeah. It might be in that, the cluster might be in that picture too, because one of these stars, either alpha or zeta, whatever that is always had trouble with this one, Xi. That star is just in the edge of the field of view.
Okay, it says it's Alderamin, Alpha Cephei on the right.
Okay. So that would put this IC right. So if you go down from alpha to mu and then do a 90-degree turn, you should see that cluster. So you go here, do a 90-degree turn, assuming this is the right way, and this must be the cluster they're talking about.
Mm.
Yeah, that looks good.
Yeah.
Not a real dense cluster, but good enough.
Yeah. It's not a real dense cluster, otherwise it would have an M or some other NGC designation. IC is kind of scraping the bottom of the barrel in a certain sense.
I like that little triplet over there too, to the right and down.
Yes.
There's another one up above. Yeah.
Yeah. Now that one caught my eye too.
Little mini Orion belts.
Yeah.
And this looks like a little miniature constellation of Cephas. And then
now, is the garnet a precious stone that is red like a ruby?
Yes.
Yes.
They make sandpaper out of it.
You can go up to the some Canadian rivers and you can mine the streams for garnets that are about 1 millimeter or 2 millimeters across. And yes, they do. It's a very hard material and they make abrasives out of it. And red. This is a close-up photograph of Mu showing the nebulosity that's around it. Remember, all colors in this are false. They're just assigned by the camera and whatever filters you used. So this probably has a lot of H alpha in it, so it's red intensive. It does show, you can see the difference of red out here. It's overexposed in the middle, so it's white. These stars are white too. They're probably not overexposed.
Jerry, just from a question from me is that I always get this wrong. This is not a red giant. It's different.
This is like a hypergiant.
Yeah.
But it goes through some kind of variable phase of color. And
carbon stars do that.
So it's a carbon star.
Okay. Yeah, but that's a generic term too.
Okay.
It's not another Betelgeuse?
Yeah, it is kind of.
Exactly. And it fits the same model as Betelgeuse. So this thing is getting ready to blow, just like Betelgeuse is getting ready to blow. So it fluctuates between around fourth magnitude, so from almost 3.5 magnitude up here to 4.5, and sometimes down to fifth magnitude down here. So every magnitude is a change of 2.5 times in brightness. Wow. So going from 3.6 to 4.6, that's 2.5 times dimmer than the top one up there.
And when it's dimmer, it tends to look redder. So that's the times to look at it.
Yeah.
Oh yeah, it's really neat when it's real red. It's most of the time lately it's just kind of an orange.
Uh-huh.
So we're in the upper part of that cycle.
Yeah. So this shows the size of the star, Mu Cephei. It's a red hypergiant. This is the inner solar system of our solar system: Mercury, Venus, Earth, and the Moon, and Mars. And then here is the sun blown up. And the Mu Cephei is on this scale, not this scale.
Yeah.
It's huge. It is huge.
Yeah, it is huge. It would easily soak up Mars. Now, when stars get real big like this, they're not as dense at the surface. They are officially, that is the size, the visible size of the star, but it can be very tenuous. you could in principle send a properly shielded spacecraft through the star.
Really?
At
Oh.
the very edge, you could skim along it and survive, except for the heat. But it's not very dense.
I've heard that the photons take thousands of years inside our sun to get to the surface and then emanate out.
100,000 years.
How many?
100,000.
Yeah.
All right. How long do they take in Mu Cephei?
Well, it's less dense, so they'd come out faster as they get out farther.
What happens in the sun is the photons hit an atom and they get absorbed. Then the atom re-emits.
And it re-emits in a random direction, so they don't always make progress getting out.
Mm-hmm.
And they come out at different energy levels. So you could get one very energetic photon turning into two less energetic photons.
Yes.
But deep in the center of that one and in Betelgeuse, it's about to make iron and it's going to be all over.
This one is actually, right now, it's fusing helium into carbon.
Oh.
But the sequence goes quickly after that. So
yes. Yeah. Our
Well,
sun is smaller, so it has less collapse heat. So it doesn't have the mass to really drive the temperature high and fuse all the higher elements. So eventually it will, as you point out, get to iron, and then it will stop and the whole thing will collapse and it will form a core collapse supernova.
Well, if I'm not mistaken, helium is element 2, carbon is 6.
Yeah.
Things are going fast between 2 and 6. Does it jump to?
Yeah, but then they fall back. The carbon decays to fill in the elements that it passed up.
Oh, is that right?
And carbon also acts as a catalyst for other reactions too. So you start to get all these other heavier elements made relatively quickly.
Yeah.
Wow.
So at this mass, it is very likely to become a black hole rather than a neutron star.
Say that again, Jerry.
At this mass, when it does its core collapse, when it stops fusing and there's nothing pushing out, the gravity pulling in wins and it will crush down, and it's very likely to become a black hole rather than a neutron star from the modeling they did.
Okay. Are there ever any white dwarfs in this system, or is that something else? That's nebulosity.
That's stars like our sun.
Yeah.
Well, that become white dwarfs.
Yes.
Yeah.
Our sun won't turn into a black hole.
No.
No, never.
Wow.
Couldn't do it. Even if you stomped on it, couldn't get it down.
Yeah, the radius of Mu Cephei, it would go from the sun out between the orbits of Jupiter and Saturn. I mean, it's just huge.
Well, if they could put a probe inside the surface, would the radio waves get out and get back to us?
Sure.
Not if it's a black hole.
Right, that's the only right.
Yeah.
I'm talking about the system, the lighter, the less dense.
Yeah, but the heat would burn it up.
Wow.
What's its name? The probe that we have around the sun. What's
Parker probe.
Parker. Yeah, that's it. Yeah. I think it just took its closest approach to the sun, and it's about to do one closer, and then they're going to have it burn up in the sun.
and Ron, this in Mu Cephei, this is so tenuous in the outer layers that you could fly something through it and it wouldn't get that much heat, really.
Yeah.
It's kind of like the corona, where it's technically very hot. The molecules or the nuclei are moving quickly, but there aren't that many of them.
Did it start out as the size of our sun and then swallow up its inner planets?
No.
You don't think
planets are very small relative to stars?
I'm talking about Mu Cephei or Betelgeuse.
Yeah.
They started out when they were born. They managed to do a deal to get a lot of mass in there, much more than our sun started with. So they burn hot. The core, because of gravitational collapse when it first formed, the core quickly went up to very high temperatures. It very quickly burned through its hydrogen to helium phase, and now it's at its helium to carbon phase, and it'll go through that and subsequent stages very quickly.
I'm looking at Wikipedia here, and it says that Mu Cephei is between 2,000 to 3,000. Wikipedia says 2,000 to 3,000 light years away.
Yeah.
I don't know what it is I use. I think it's 2400 that I use at outreaches, but it just looked like a normal little star in the sky. You would never know it was that big.
But aren't there blue giants that are really hot?
Yes.
There are.
Okay, so the color makes a difference.
The color indicates surface temperature.
Yeah, that we wouldn't be able to approach. But,
and even a blue supergiant is nowhere near as big as a red supergiant.
Yeah.
Okay, and Betelgeuse is doing all kinds of strange things that they can detect from this far away.
Yep.
It's ballooning up and subsiding, and is this doing the same thing, Musaifi?
Betelgeuse is closer, so we can get more information from images of it.
Maybe on this strange election year, both of them will decide to blow. Wouldn't that be something to Mother Nature? Maybe on November 5th.
Now we need to cool everything off.
Yeah, we sure do. Gentlemen, you did good. I learned a lot. I'm going to go think about it. We'll see you again, I guess, next Monday morning. Meantime, I guess Friday night, if it's like it is right now outside, we'll be there at the observatory at Westmont. And on the night of the... What?
Bring your moontan lotion.
Oh, yeah. That's right. And otherwise, on the night of the 2nd, that's 3 Fridays away, or 2 Fridays away, I guess. We will be there with Dr. Volganov to talk about beer and the dust clouds. You're not going to believe that speech. We'll see you next Monday morning right here for SBAU's Astro Hour. I'm Ron Heron on behalf of the guys. Thank you, SBAU.